Really long topic, but I'll try and keep it short and sweet. So, touching upon aspects. Today, my co-presenter is Dr. B.V. Kumar. This is an academic collaborative effort. I am Bhargav. I work at Pci Information Security. We are security consultants. And Dr. Kumar works for Cognizant Technology Services, which is a software development company. Basically, we are going to split this session into two mini sessions. First of all, I'll be talking about the payment card industry and application security. And then Dr. Kumar will be talking about the security implementation for the PCI industry using the new Java EE. So basically, we're going to touch upon the design aspects of applications for the PCI environment for PCI compliance, and few implementation requirements. Because of the paucity of time, we'll not be able to cover everything, so you can take your questions offhand as well afterwards. So first of all, what is the payment card industry, and what is payment card industry compliance? The payment card industry compliance was created for companies who store, process, or transmit cardholder information. When you say basic objective of the PCI standards is pretty simple. Protect cardholder information. Do not allow it to get leaked. Do not allow the disclosure, intentional or an unintentional disclosure of cardholder information. So any company which stores, processes, or transmits cardholder information needs to be compliant with the PCI standards. So who needs to be compliant with the PCI standards? We'll get to that a little bit later. We'll just give you a timeline here of the PCI landscape. First of all, this is the Security Standards Council. The Security Standards Council was created by 5 payment brands: Visa, MasterCard, Amex, JCB, and Discover. And they promulgated the PCI standards, which started off with the PCI 1.0 in the year 2004. In the year 2006, they made it PCI DSS version 1.1, which is what we're currently following. And apart from that, application security took a big leap when the payment application standards were created. I don't know how many of you have heard of PABP. How many of you have heard of Visa PABP standards? It's called the Payment Application Best Practices, which basically talks about an application which needs to be deployed in a PCI environment. The newer standard of the PABP is called the PADSS, which has been taken over by the Security Standards Council. So now it is an industry-wide initiative to promote secure payment applications. Any application that stores, processes, transmits, or even sometimes displays cardholder information. So this is just a brief evolution of the PCI standards, so to speak. Now this is basically a, This is a graphical representation of a very simple process flow of what really happens when you go into a merchant's establishment and use your card. So you are the card holder. You go to a merchant. The merchant takes your card and swipes it on his machine, right? So then the transaction moves to the acquiring bank. This is the bank the merchant is tied up with. The merchant's transactions are acquired by this bank. So this is the acquiring bank. At first, it's the acquiring bank. The acquiring bank then pushes it to the card payment brand. Let's say this card holder is having a Visa card. It pushes it to the card payment brand, which is Visa. Then the transaction moves to the issuing bank. This is the bank that issued the card holder's card. So it moves to the issuing bank, and then the issuing bank does a bunch of checks, basically checks out if this card is okay, if it actually is owned by the issuing bank, and then comes back to the card holder, and then the transaction is authorized, and that's how the debt trap begins. So apart from this, there are a little more complex entities which require to be PCI compliant. You can obviously understand that all of these entities, apart from the card holder, need to be PCI compliant. But there are some more entities as well. Let me add a little complexity for you. Here, there's an extra entity. Let us say this merchant has a BPO in Bangalore. That's where I come from. A BPO in Bangalore, which is taking calls on his behalf. So the BPO is actually it's accessing the merchant's cardholder information. So that is a service provider. So the BPO needs to get PCI compliant as well. Now this is another service provider. What happens is the acquiring banks seldom like to acquire transactions themselves. What they do is they outsource the transaction processing to someone known as a third-party processor. A third-party processor allows his network to be used for transmission of cardholder information. That is done by even the card payment brand as well as the issuing bank. So all these banks have third-party providers providing processing capabilities for them. So these guys need to get PCI compliant as well. But there's something else. I don't know if you can see this. Can you see application vendor in each of these areas? Just, it is a service provider or application vendor. Why does an application vendor need to get PCI compliant? Let us say the merchant is using a retail automation solution. Let us say company X designed a retail automation solution which it wants to sell to various merchants. Let's say A, B, C, D, E merchants. And it goes to the merchant and says, hey, here's my retail application. Do you want to buy it? He says, no, I cannot buy it. It is not PADSS certified. If it's not PADSS certified and I'm going in for PCI compliance, I won't pass the compliance because your application is not PADSS certified. So the retail automation solution, the company X goes in for PADSS certification for that product. Let's say the product is X and X product gets certified PADSS, and then it can be deployed in a PCI environment. Basically, the PADSS was created to support a PCI compliant environment. So any questions at this point? Yes?
So what you're showing is actually the flow of transactions.
Yeah, it's just...
The flow of funds would be like a different flow.
Yeah, I mean, this is just a basic flow, a very simple flow. I mean, there are much more complex flows as well, but just for your understanding, this is just for your understanding here. So this is basically an extension of the slide previous. So what does it take to get PCI compliant? Most clients we visited have a big problem. What really does it take? What really needs to get into a compliance process from their end in order to get compliant? First of all, identification of the flow of cardholder information. We spend around 30 to 40% of our time on assessment in determining a flow of cardholder information in the environment. For that, we need process flows. We need how does the application or the entity itself take in cardholder information and output cardholder information. So this basically can be determined by some flow of cardholder information that is done through process flows and business flows and things like that. Then, of course, PCI mandates security policies and procedures, which need to be documented, which is part of your standard ISMS process. Also, network and security implementation you require firewalls, IDSs, IPSs, all to be in place in order for you to get PCI compliant. Of course, the topic of today is also going to be discussed. We're going to be talking about this in greater depth. And of course, risk-based implementation for optimized security. Not all applications or not all entities carry the same amount of risk when you're implementing PCI. It depends on their exposure to cardholder information. It depends on how much cardholder data exposure they have while implementing their controls, because the controls need to be on a cost to benefit ratio as well. So what has an application got to do with PCI compliance? The application has got a lot to do with PCI compliance, because today we have complex applications which are able to store, process, and transmit cardholder information. You're talking about e-commerce servers. We're talking about processing applications. We're talking about, recently I performed an assessment for an image capturing application, which captures scanned images on form and allows data entry operators to key in those images into a data file. That, if it captures cardholder data, that becomes an application which has to do with PCI compliance as well. So PCI compliance is quite pervasive when it comes to cardholder information. Any application facilitates storage, processing, or transmission, or even display, like I said, needs to get PCI compliant. So this is one of the first important requirements of PCI. I'm sure most of you in this room would know quite a bit about it. Authentication and authorization. You can't have a 2-character password or a 4-character password. You need to have at least 7 characters, alphanumeric, basically. And apart from that, you need to also make sure there are password lockouts. If you enter the password wrong more than 6 times, your account needs to lock out. Session time needs to be implemented to not more than 15 minutes. Things like that. This is basic. This is what most applications need to do, is something like this. PCI also requires a list of users who have access to cardholder information. Let's say you're a bank and you have users who are accessing cardholder information, and you'll probably have a long list. You need to make sure that each of these people actually require to have access to cardholder information, and what kind of access they need to have to cardholder information as well. So also, the authentication and authorization needs to take care of invalid authentication attempts. Let us say, like I said, password lockouts, password resets. A password reset should last for a minimum of 30 minutes is what PCI requires you to do. So authentication and authorization I won't dwell upon because the other sections are quite critical. Now, like I said, this is the underlying message of the PCI. The ultimate objective is to protect cardholder information in storage and in transmission. Now, this can be quite tricky, actually. First of all, you need to realize whether you need to store cardholder information at all. Many times, in many companies, you won't really require to store it. You'll be unnecessarily storing it and increasing your risk most of the time. In many cases, like for example, a data entry company, let's say an offshore data entry company back in India, they would many times not need to store cardholder information. So when they go in for compliance, they would realize that this is not really required for them. So they would purge the data and actually reduce a lot of risk for their customers and themselves in the long run. What elements can be or can't be stored? PCI has a set of elements which can be stored and a set of elements that can't be stored. Like your 16-digit number, which is called the PAN, can be stored, but it needs to be protected. It's called the PAN, the primary account number, the 16-digit number on your card. Name, expiration date, and service code can be stored. The sensitive authentication data, which is the CVV, I'm sure you know what a CVV is, the three-digit number on the back of your card, which is used for authorization, can never, ever, ever, ever be stored. So please make sure that you're not storing CVV, PVV, Magstripe data. Magstripe data is basically when you swipe your card, the magnetic stripe has a lot of data, which is track data. That cannot be stored. Except for these elements, the PAN needs to be protected as well. So only the PAN can be stored. Now the PCI standards require the PAN to be rendered unreadable. That's the verbatim. PAN should be rendered unreadable. So what are the strategies you can employ for rendering PAN unreadable? It's basically these three things: encrypting, hashing, truncation. When we're talking about encrypting, of course, you have this key management which kicks into play as well, because you need to manage keys as well. Hashing, many companies do hashing, but the thing is, when you hash, if you're a merchant, you can never hash because you need that card for chargebacks. And hashing is a single-way process, so it's impossible for you to recover the card number for chargebacks. So merchants cannot, they don't find hashing to be a very, very good way to protect cardholder information. Truncation as well. Many of the processors are adopting truncation because when they process transactions, they won't need to know the card numbers. They won't need the card numbers. You can guess why? Because they are just the pipe through which cardholder data is flowing. So they won't need to store cardholder information. So many processors we've been assessing are going in for this option of truncation, where you fuzz out everything but the first 6 and the last 4. That's what's allowed by the PCI. So when it comes to encryption, you also have this added requirement of key management. When we say key management, most of the time, many companies prefer hardware security models. How many of you have heard of hardware security models? I'm sure. Hardware security modules are supposed to be the most safe because your keys never leave the system. Keys never leave. It performs the key management from the system itself. Even a small shake of the hardware security module and it will switch off and it will purge all the data inside. Hardware security modules are supposed to be very, very secure. But many times this is not an affordable option. This is not an affordable option. So there are equally good key management frameworks out there. There are some from Java. There's OpenSSL. There is also Strong Key. There is a Strong Key implementation, which is all open source. So you can probably consider thinking about this for your key management requirement. When it comes to key management, what is the encryption algorithm you should use? Basically, I would suggest PCI has basically talked about AES-256 and S-128. Also, apart from this, if you read the NIST document, NIST SP 857, it specifies a list of algorithms which will be secure beyond 2030. So you can use that for your reference for key management as well. That is pretty good. So key management, some of the ground rules: don't use passphrases for keys. That I think is pretty simple. Do not use passphrases. Generate strong keys. So automatically generate strong keys. And apart from that, don't store your key encrypting keys in the database. If you store your key encrypting keys, if your database is compromised, then your entire data set is compromised. So that will cause pandemonium. And especially in companies like merchants who will be dealing with cardholder data in and out on a daily basis, key encrypting key in the database, not a good idea. So these are some key management strategies for PCI compliance. Moving forward, this I think is the most underutilized and abused requirement of the PCI, until at least the PCI came along, which is logging. Logging is considered unnecessary overhead, it's considered too much, it's considered not worthwhile. Even if that's true, you're required to do it if you need to get PCI compliant. What application activity has to be logged? First of all, consider what you're logging. You need to log things like this: user info, time and date, system data affected, success or failure. But many times, applications go unnecessarily beyond this. They log unnecessary attempt. They log unnecessary information. Oh. Sorry, folks.
I need to log.
What happened?
I don't know.
Yeah.
ಸ್ವಲ್ಪ ಬೇಗ ಹೋಗ್ಬೇಕು.
Sorry about that, technical snag. Yeah, so most of the times applications log unnecessary information. Like processors have a big problem with application logging. Their application logs, they have something called financial switches, which facilitate the payment process, which facilitate the flow of cardholder data. They log everything most of the time. They log everything in clear text. They log the PAN, the CVV, the PVV, the entire track data in clear text. That is blasphemous. That is just unacceptable. So you need to do something about that. So logging of cardholder information should just not be there, and make sure your transactions are not logged unnecessarily. Secure coding, I think I will not be preaching much of secure coding because all of you have sat through presentations on this from the morning, and I'm sure you've discussed this from the experts. Owasp has been extremely great in terms of providing a lot of knowledge for secure coding in terms of the Owasp top 10 and the other requirements. Of course, needless to say, I'm sure many of you sat through the industry panel discussions, must have realized by now that secure SDLC is the mother of everything. So you need to have a secure SDLC process and make sure that that process is learned by rote by everyone in your company. Of course, secure coding practices, I'll just touch upon some of these: input validation, error handling. Following the best practices, Owasp top 10 is a great way to start to secure. In fact, the PCI requires you to go by the Owasp top 10 as well. So training developers for secure coding. These are some of the basic implementation requirements you need to have for PCI compliance. Of course, the requirement 6.6, the infamous requirement 6.6, which I'm sure many of you have read over the past months all over the internet, in blogs, and I'm sure if you ask any of the vendors out there, they'll tell you what requirement 6.6 is. You need to either put a web application firewall or do a secure code review for the latest application vulnerabilities. You need to do either of that for your web-facing application, not all web applications. For your web-facing applications is what's prescribed. So that's requirement 6.6 for you. So this is my last slide. Implementation, everything else. Now, PADSS requires you to have an implementation guide for your application because you might have designed your application perfectly for your customers to use, but many times if they don't know how to use it, and if your guide doesn't tell you how to use it, that is going to be of no use as well, because in the real world, they need to know how to use it. Training, of course, this goes beyond saying. Implementation and training go hand in hand. Maintaining compliance. This is a thing what we've found as well, because when you're getting PCI compliant, there's that entire drive to get PCI compliant, but afterwards it slackens a little bit. So make sure that you maintain compliance, because PCI, if it's breached, if you're guilty of a card breach, you would find that there's some really steep fines and some enormous costs to pay when you've breached, when your data has been breached or when your company has been breached, either way. So please make sure you maintain compliance. So I would hand over to Dr. Kumar to talk to you about some of the PCI security implementation strategies, Java EE style. Thank you very much.
Thank you, Abhay. Before I go, let me tell you a little bit about this collaborative work. I come from Cognizant Technology Solutions and he does not. He comes from CISA, and they are one of the people who certify the people who does applications for PCI and any other applications that work on the web. So are one of the fastest growing internet IS internet services service providers in the world. We do have quite a huge number of clients for which we do develop applications that work on the web, not necessarily PCI, and CISA does certify, and they have already certified us for many of our applications that we have created, and they are for large Fortune 500 and Fortune 1000 clients, and they include customers who does the banking, finance, insurance, and retail applications particularly. And some of the things that we have included over here is, he talked a lot about the PCI compliance, PCI standards, basically, like, what do they talk about it, what should be protected, what should not be protected, how you should do it, what is the security relevance of the applications that needs to be developed. He talked about it in detail. And then, what does the PCI compliance states, what needs to be protected and who needs to be protected. Like, he talked about a lot of people who appear on the horizon when we talk about the way the transaction that do happen. It hops from a user to the merchant to the vendor and so on and so forth, and to the banking. Everyone needs to be complying to some of the standards. And so let's assume that these are the people, these are the merchants, or these are the banking applications that needs to be created. It's not just a single application, a host of applications that has to be running, and there are many ways of creating these applications. We have focused in this particular work on the Java or Java EE based applications. Okay, we do not say that this is the best way or this is the only way. This is the way we found out one of the best ways of creating an application. As Java has, you have already seen that it has appeared on the horizon a decade ago, more than a decade ago, and has become the application programming environment of choice for most of the IT service providers. Having appeared over a decade, Java has changed a lot, and very recently Java has introduced, Sun has introduced, instead of, we started talking about Java earlier, and then Java J2EE appeared on the horizon, and it carried almost till last couple of years ago. It became J2EE 1.1, 2, J2EE 1.3 and J2EE 1.4. Till then, it used to do almost the same kind of a thing, and later on Sun introduced a lot of changes the way programming is done in Java, and that is exactly what I'm going to focus on. So they changed the name of Java, Java 1.2 to Java 6 and J2E 1.4 to Java EE 5. Okay. They didn't just change the nomenclature, they introduced a lot of new things, and that has resulted, in fact, for us, the way we can create applications is going to result in the time to market easy and quicker fashion. And what are those features that has affected, like the Java language features? A lot of language features that has made Java easier or a preferred way of programming. Virtual machine, the base libraries, that has been changed a lot. In fact, the latest of the base libraries that has been changed includes networking libraries. For example, the most advanced networking features have been introduced that includes the way to handle IPv6 instead of the old IPv4 kind of networking libraries, and also the security libraries that have been introduced includes the SSL engine itself. And the integration library includes remoting, the remote method of invocation has been enhanced to take care of dynamic generation of RMI stubs and skeletons within the programming environment. These are the things that has made Java EE quite a bit different and has resulted in a quicker and easier way to develop applications, providing the compliance standards what the industry is asking for. While I talked about the Java SE, that is the standard edition part, when we talk about applications that run on the internet, Sun calls that as Java EE5, that is Java Enterprise Edition 5, and that takes a lot of things from the Java 6. However, what is new in Java EE5 is some of the things that I have listed over here. EJB 3.0, this is the easier way of creating enterprise Java beans. They are the business components basically. Java persistence architecture, which takes care of securely writing the information into the databases. Web services has been integrated with Java EE5 now, which will allow you to communicate with the disparate programming environment. Java Web Tier that has been introduced along with the JSF allows you to quickly create a web application with more or less you don't even need to put your hands on the keyboard. With several clicks of mouse and a database at the back end, you should be able to come out with an application. Probably the first cut application is going to be very fast. And also the J2E blueprints for Ajax based Web 2.0 application, which uses Dojo toolkit. We have gone beyond Java, we use scripting, which has become one of the most accepted or probably most popular way of programming web applications. We kept on talking about web applications and enterprise applications. In between, we started talking about components, business components and web components. I want to have a quick clarification over here. And in fact, even my friend projected beautiful graphical images wherein he talked about a client, he talked about a merchant banker, he talked about a financial system in the back end, and so on and so forth. What they are basically the applications are created and loaded on these systems. For example, a client application would run in the place where the client is using a system, and the server application would run. It could be one or more servers, where it could be a database server, it could be an application server, it could be a web server, and so on and so forth. And the client application could communicate with the such server applications, or directly, or through middleware applications, which could perhaps add a lot more value into what the clients are looking for. Okay, and these applications can be created using many many directions, many environments that are available. It could be a PHP based application, it could be .NET based applications, or Corva based applications, or Java J2EE based applications. I'm sorry, I should say Java EE based applications. And our focus presently is on the Java EE applications, because most of our such applications, for most of our clients, we use the Java EE environment. We talked about the three applications, different applications. The client applications could be an application that run in the client environment. It could be a standalone Java application, or it could be a Swing based Java application. Okay, and most of us know, like, it could be a desktop browser which will be using a applet, and the applet could be connecting to a server application or through the middleware. Okay, and even scripting applications which currently using script based applications, and Java Sun has introduced a new scripting based application which is called as JavaFX. Even such applications can be used to quickly come out with an acceptable user interface based application to connect through the internet to our backend application, which is currently a PCI based application, or an application that is for the payment credit card industry. On the server side, to make the things easier, the J2EE or Java EE applications can be broken into, instead of we call that as an application, we call them as components, and these are the components that run in the containers, and the containers are going to run inside the servers. Let's not get into why we say containers and servers at this point in time. Probably, like, we can take a look at that a little later. Containers can be roughly classified into two different types of containers. One is called as a web component running inside a web container, and a business component running in a business container. And as the name itself indicates, a presentation related component is created using the Java EE based web components, which are servlets, JSP, JSTL, filters, helper, and utility classes. I hope, like, how many of you guys are Java EE programmers here? Okay, so I'm very, very happy that, I'm talking to some of the guys who can understand what I'm talking about now. I'm not saying that these are the latest things that is available only in the Java EE, that they have appeared long ago, but they are being used in a most updated fashion. And the business components are those things which hide behind the web container, and probably they might exist in the same machine, or they might exist in another server, depending on how you configure, how you architect the PCI application or the payment credit card application. The business component side, we have session beans, entity beans, MDBs, or the message driven beans. These are the things that takes care of managing sessions, managing the data, persistence, and managing communication with the middleware. Okay. And the other applications, which basically we say that these are the applications at the end are going to go and connect with some of your applications. That could be a SAP application, wherein it is going to update the transactions when it goes through. Okay. So what does the client application need to do, and how is it going to do? So the client application needs to take care of the application requirements, or in this case PCI application requirement, and they should securely execute in a desktop or a browser environment, and of course they have to be compliant to the PCI requirements. On the server side, what should these components or application be doing, and how should it needs to be taken care of. On the server side, we have to take care of two things, actually three things. Business logic has to be taken care of, what needs to be happening according to the credit cards business logic. Presentation, how it should be presented, which actually talks about the web part of the application, and also the non-functional requirements. Although it says non-functional requirements, it takes care of several things, which includes security. Everything like other than the functional requirements is a non-functional requirement for that matter. Security, let's say scalability, reliability, so on and so forth is a non-functional requirement, and most of such requirements come through the vendor supported, vendor provided application servers, which of course is a Java or J2EE or Java EE server in this case. Server components are two types, as I said, web components and business components. Web components take care of presentation logic as demanded, and business components take care of business logic as demanded. Okay. And these components interact appropriately to achieve whatever is the application that needs to be doing at the as prescribed by by our client and according to the PCI requirement. Okay. After having said that, positioned like what are the business components doing, what are the web components doing, and what are all the non-functional requirements, let's take a look at some of the things that he talked about. I have captured only a few of them and position how the new Java EE is going to help us. Some of the things that we captured are the logging API. He kept on talking about logging needs to be done. So I am going to say like how logging is going to, how Java EE is going to enable you to do the logging. He kept on saying that the client has to be authenticated and authorized. Like I will position how Java, the Java EE side of the JAS, we call this as a JAS, it's going to help you. And he said that it has to be masked, it has to be hashed or whatever, how it is going to happen. So I am going to deep dive in the next 5 minutes as to how it is going to happen. I am not going to talk much about it because on the client side it is like I have already talked about it, so I will not talk much about the client side. And what are the applications on the server side, like based on the industry that we have talked about. I will also add another caveat here that I am not just saying that Java EE is just for PCI industry. We take a look at what is the security policy described by the application. In this particular case, it is the PCI which is the security policy that has been enforced, and now we have a governance based on that we can take care of the how to build these applications. On the server side, we will have an e-commerce server which will be running a financial application, a database application, and probably a workflow application which takes care of how the hops has to be made to where it has to go and things like that. And on the payment, probably a payment gateway, that's what he also mentioned, which is also going to be a server application for me, which is going to establish connectivity between the e-commerce server that we talked about earlier and the backend banking application, which is the banking banking guy who is going to be as a part of my workflow. And the banking application is the guy who is at the end, who is going to ensure the payment that is going to be making for that particular transaction. He is going to do the card processing. Okay. These are my last few slides wherein I will go deep dive. As I said that because we are talking about security, we have picked up only the security part, and in this we say like for any application the security strategy depends basically on the security policy of the company which is using that application. In this case, that is governed by PCI. Okay. and he has given a list of several things, the list of 14, right? 14, the PCI standard wants you to enforce those 14 standards, and most of them fall into the following categories: the logging, authentication and authorization, encryption, secure storage, or secure or secure transmission. So I'll pick up one by one. Let's try to go deep into that. Logging is taken care of within Java EE environment using logging APIs. Okay, logging API is not new. In fact, it was not existing at all. Okay, somebody else generated logging APIs. It became popular. So Sun merged the logging APIs with the Java EE environment. Authentication and authorization, it was existing, and probably it has been now upgraded, and actually Sun has introduced what is called as a JAWS framework, and the JAWS framework is going to help you in doing the authentication and authorization. I'll give you a little bit more details on that. And encryption and cryptography is not new. However, like it has been happening, but nowadays the encryption, according to the requirement of the industry, the encryption and cryptography has been grouped under a single umbrella called JCA, that is Java Cryptography Architecture, which comprises JCE, which is Java Cryptography Extensions, and Java GSS, which is Generic Security Services. And also Java EE provides along with it what is called as a set of tools, toolkit, which is going to enable you to probably do the key management or signing or enforcement of the policy and so on and so forth. Okay. I will get into these things very quickly. Like, I do not have much time left, although I request for a couple of minutes over here. Logging APIs, if you use it from the Java EE side, it is going to allow you to deliver logging at 5 different levels. The least logged information all the way to the highest logged information you can choose, and then depending on what you want, your application go through a logger and a handler, and then it goes to the outside world. So depending on what you want to use, you can use a set of filters at the logger stage and a filter or a handler at the formatter at the handler stage. Authentication and authorization, as I said, Sun has provided you, and in fact not just Sun, any of the Java EE vendors. It could be IBM, it could be Oracle, it could be any other guy whom you are talking to. They do provide, based on the APIs as well as the JSRs, frameworks have been made available. Okay. Very quickly, authentication and authorization go together everywhere. Okay. So Sun has created actually 3 common classes which takes care of the authentication and authorization. They are very simple, but at the same time very comprehensive. It can become comprehensive and very effective when properly used. A subject, a principal, and a credential. A subject is a guy or a service who will be using the application. A principal is information about the service or the guy who is using the application, and a credential is what is the security credential of that particular thing. That is applicable to both authentication and authorization. So these classes are used in context with, if it is being authenticated, these sets of classes and or interfaces come into picture and then inappropriately handled. For example, when a subject logs in, a login context is created for him, which is going to use a login module. What is a login module here? For example, it is actually a conscious decision of your company what is the login module you are using. You could be using a login module which uses just a user name password based authentication mechanism, or it could be using a fingerprint mechanism to allow you to do the login. Once the login is there, you use interfaces, implementation of the interfaces such as callback and callback handler to authenticate a person who is the subject in this case. And once he is authenticated, you have authorization classes, what he can do, right, using these things. For example, we have a set of classes. Okay, just a very quick detail here. All those things which appear in the Courier new type font, they are the classes, and those which appear in the normal font are the interfaces. Okay. A policy is an authorization, and you can create the policy for the subject. You can have n number of subjects. For each subject, you can have n number of principals, and based on your credit card industry, your cards, your company's card policy, you can have a policy class and an authorization permission class, a private credential permission. Actually, since we do not have much time, I will not be able to spend probably some other time on this. Almost the last slide, wherein I am talking about the encryption, the third thing, like, we talked about logging in, we talked about authentication and authorization, and the final one is we are talking about encryption. As I said, JCA has become an umbrella now, and it is going to take care of several things inside. And once again, I have listed all the classes and interfaces that are going to help you in properly taking care of how to encrypt the information. Okay, like, for example, provider and security classes, algorithm parameter and interfaces and classes, a host of them are there. Key interfaces and classes will help you in creating appropriate keys and so on and so forth. And of course, like as Abhay was mentioning, Java GSS is going to take care of support for encryption of a variety of types that is demanded by the industry. Okay. And finally, Java EE also provides you, of course, the vendor of the Java EE is going to provide you with a host of tools that is going to help you in doing quite a bit of things which is required by the payment credit card industry. That includes key tool, jar signer, policy tool, so on and so forth. And these are the things that are available on almost all the platforms, and then they do follow the compliance requirements stated by PCI. So with this, I am going to wrap up this particular talk. As I indicated in the beginning, this is a work which we collaboratively did. Essentially, when we came together, when they were trying to do the certification process of many of our applications, one of the things that we figured out was that the Java EE is a new way of doing it, and it helps us in doing far more quicker, lot more easier, and then in the current context, it does fit to the requirements of the payment credit card industry, and then it can be extended to any other industry for that matter. As I said, we have already started using the new Java EE way of creating applications for for different types of industry. That includes retail, healthcare, banking, and insurance, and so on and so forth. With this, thank you. And then any questions?
Any questions on either PCI or?
Yes, about Pci Compliance. What happened with the application that require they are storing the credit card number?
I'm sorry?
What happened with application like PayPal?
PayPal. They need to get PCI compliant, because PayPal, I think, manages their own environment, so they need to get PCI compliant. PCI compliance applies to environments which need to get certified. PADSS, which I spoke about, is for payment applications that need to get certified. It's an application as well, but they also manage, so they need to get both certified.
They offer that as a product.
Yeah, so they are managing that network. So as long as they are managing, their infrastructure needs to get certified as well as their application. So they would go for it in a single umbrella. If they are reselling the application, let's say PayPal was reselling the application as a commercial one, then they would need to go for PADSs, otherwise it's just PCI.
Can you compare it to Spring Security, Java, Jazz?
Okay. Spring is also Java EE. Actually, like Spring is a Java EE without EJB 3.0. And Spring alone will not be sufficient for because Spring is also a sort of a Java EE solution. They might not be using some of the newer technologies that have been recently introduced, but still they are probably you can build an application which is a PCI compliant application. Of course, Spring does not take care of the database side. Probably you need to fix the Hibernate there. Hibernate actually right now currently they are supporting EJB 3.0 as well. So they are also going to be compliant.
Well,
I mean, if that application uses both Spring and Hibernate.
Well, there is like a question about the transaction flow, and I see that for the one that connects the merchant over to, you said that like there was this other certifying authority, which is like your own company.
Service provider.
Service provider. What can you provide more insight into what the role of that?
Okay. You want for something for the merchant? Let's just take an example, something like this. Let's say I'm merchant X, and I have a BPO in India which takes payments on my behalf. Merchant X, people call into Merchant X's call center, and they take credit card transactions on behalf of Merchant X. Now they become an entity connected to Merchant X, so they need to get PCI compliant as well. If they don't, Merchant X doesn't get compliant. You get my point? Am I making sense?
So Merchant X could potentially be a merchant that is located in the US. And then you are saying that perhaps that merchant in the US has a call center that is located in India. And that is how your law comes in as, is that, yeah, that was what I meant.
You're talking about the service provider,
Yes.
right? Yeah, that's right. Let us say even if it transcends geography, not really geographically restricted. So if a service provider, could be anything. Let us say a merchant is getting software developed by another guy, and the software is having something to do with card order information. Let's say the software is billing system, which needs to be audited. Your merchant is, offshoring that development process to another company. They need to get PCI compliant as well, because they are developing their application.
So no, when you say, is this more about credit card payment systems, or is it just about outsourcing of development?
Some restrictions, yes. There are certain restrictions. Let's say I'm from India, I'm a certification body from India. I need to apply to be a certification body in the US. I mean, it's the same, we are all in the same.
No, you meant like recognition-wise.
No.
Okay, that's besides the point. What I'm saying is it dependent on where the people are, or is it dependent on where the data is stored? Because if you're looking at certain, in terms of data management stuff, is it more about where the data center is located, or is it not? So, which means to say, conceptually wise, irregardless of where the call center is, because call center, we are talking about people effectively answering phone calls and dealing with like customer service and requests, right? So long as, then credit card information could be, like the verification process could be done over the phone. So, and then people would have to like pull out that information from a specific system for the verification process to take place. So when it comes to the certification of that, what would be the primary consideration factor? Would it be where the data is stored, as in where the data center is, or would it be more where the business operations takes place?
No, it's more on the data side. Where is your data getting exposed? Let us say, where are the chances of your data getting exposed? It doesn't matter where. Let us say, where are the chances? Like if your data is in a particular, let us say, let me give you an example. We had a bank which we need to get compliant. They have branches in UK, they have branches in the Middle East, they have branches in Southeast Asia, all these places. They have but they are all not, they're not the main center. They're not the business operations. These are just places where they are likely to get card holder information from. So we need to make sure that all these places are subject to the same amount of controls. They are subject to controls of the system.
So you're saying that from the certifier's perspective, what would be the primary consideration is therefore not where the data is stored, but where the transaction flows and it's more about information flow, and that is fundamentally different from data management, data storage.
That's right. That's the flow of information. Where does it flow? Where is the exposure? Okay.
So then, in terms of certifying, you're actually certifying the process, not
Yeah.
just.
Yes, that's right. You're certifying the infrastructure and process.
Not just data.
That's right. Okay. That's okay. Thank you.
Thank you.